All right, welcome back. Hope you enjoyed your coffee and the short break. Next up, we have a developer from a fabulous team at Greylock. He's also responsible for new features, doing some work, fixing bugs, and I would like to give him a warm welcome and enjoy his talk. It's Jochen Schalanda. Please, welcome.
Yeah, good morning everyone, and thanks for joining my session about digging in the dirt. Let's start with a small informal poll. So I guess you're all professionals here. I'm sure you're all professionals here, so you know what logging is and what the value of logging is, and I'm sure you're already collecting all the log data of your environments, of your applications, of your network devices in your companies. So you have to use something to collect those, and I'd like to know what you're using. So who's using the Elastic Stack, like Logstash, Elasticsearch, and stuff like that? Okay. Who's using Splunk? Oh, you got money. Okay, and some software as a service provider, like logging SaaS. Okay, not that many. And who's using Greylock? Yes. Usually just one or two hands will go up, so I'm glad that there are more people here using Greylock. So, why centralized logging? Of course, you all know that already, but just a small recap. First of all, it helps you debugging your applications. So that's more from a developer point of view. Like, you want to debug your problems with a distributed system, and now you have to look at the logs, and you realize you don't have logs. So, yeah. It's a vicious circle, but in the end it's that, helping developers finding problems in their distributed systems. Also, it helps you probably find why that single email wasn't sent out by your SMTP server to that one location. So there's value in that. And then in the last years, centralized logging came more into the spotlight as a part of a security strategy. So there was this very nice blog post, learning from a year of security breaches. Can everybody see the slides, by the way? Great. This great blog post there, which was looking at all the security breaches that happened in the year 2016. And basically, it turns out that the whole story about basically each security incident could have been either detected much earlier or even prevented if there was a good logging in place, which had recorded the breaches and the exfiltration attempts of the attackers. So that's another quote from this article. I won't read it out, so you can check it in the slides. And just recently, I think it was end of last week, or it was even this week, the new OWASP Top 10 came out. OWASP is an organization dedicated to teaching developers and operations people about security breaches, security problems in web applications. And the Top 10 is just a list of basically bullet points that you have to check against your web applications to have basically a minimum protection against attackers. And new this year was one problem, insufficient logging and monitoring. It's way too late that they added this, but just to mention it here. So, what's our schedule for today? It's a Fahrplan. Basically, I just want to give a very, very short overview over Greylock, and then jump into a live demo in which we will capture DNS, HTTP, and ICMP packets from a playground system running on my laptop here. We'll send the connection and packet metadata to Greylock, and then we'll do fine things with that, like cleaning up and consolidating the data so that we can actually make sense of it and throw away everything that we don't need. We'll check against online threat databases like abuse.ch. We can check if there are Tor nodes, Tor exit nodes among the destination addresses and stuff like that. And we'll show shiny stats on dashboards because everyone wants dashboards, right? That's why you're using the Elastic Stack with Kibana. And then maybe if there's enough time left, we'll alert on these threads. But that's pretty fast. So, Greylock. A few of you have already been using Greylock. If you haven't, so I'll give just a very, very rough overview. Greylock is an open source management platform, log management platform. So it's basically in the same league or the same space as Splunk and the Elasticstack is. So you can ingest all the log data you have in your environments, be it from network appliances, from your custom applications, or from standard applications into one place, and then analyze that data. It's built for security and operations, so you get, out of the box, you get all the stuff that you need to consolidate your logs, to check your logs against threat databases, and to build your dashboards that you want to show on your big screens. It's usually easy to set up, and it has powerful features. So easy to set up means we have so-called virtual appliances, which you can deploy to your VMware, your Hyper-V clusters, and then run it all in one, and it's even clusterable. And powerful features, we see about those on the next few steps, and it's extensible via plugins, so you can extend it. And then we also have a commercial offering, and I promise this is the only and last slide about that. So if you're using Greylock or plan to use Greylock in a professional enterprise environment, just talk to me afterwards or contact us over the website. So Greylock as a central log management platform, it can collect logs from your typical syslog sources like most of the network appliances. It also speaks CEF, which stands for the Common Event Format, which is being used by ArcSight, I think, mainly. And it also has a proprietary format named GELF, the Greylock Extended Log Format, which is nowadays supported by most of the programming languages, programming environments around. So your JavaScript and PHP and Java applications can basically log in a structured way to Greylock directly. It also supports the Beats protocol, which is being used by all the nice small programs provided by Elastic, like FileBeat or MetricBeat or PacketBeat. And in today's demo, we'll be using PacketBeat to collect the network data from there. It also supports NetFlow, version 5 and 9, so you can also send your network flows directly from your switches and routers into Greylock. And just to continue, there are lots of other formats, but I won't go into these. So that's the Greylock marketplace with lots of useful plugins like the Space Weather plugin. So you can check if sun flares caused your outages. Yeah, it's important. We also have a very vivid community where you can ask your questions. Also, the developers take a look there, so you'll probably get an answer from first hand. And that's the first look at Greylock itself. That's basically the starting screen. It's called the universal search in this case, where you can see basically an overview over your ingested log messages, how many log messages have been ingested over time, and basically just start your search queries. So it's not different from Splunk or from having, old versions of Kibana. As mentioned before, you can have a shiny, colorful dashboards there. So I'll just show it so you have an idea of how Greylock does look like. With the typical widgets like top-end tables, histograms, and of course the infamous map widget, which everyone needs, but which is not very informational, but okay. And another one. Okay, and another feature which I won't talk about today too much is the collectors. So it's basically a sidecar program which you can use to set up other log collectors like NXLog or FileBeat or WinLogBeat on your client machines and manage them centrally in Greylock. So it can be either an extension or a replacement for your usual configuration management programs. You can see if they are live, if they collect logs, stuff like that. You can configure them on the fly. So that's useful if you have a large fleet of computers that you like to collect log messages and events from. And yeah, let's start digging. That's already where we go to the live demo. Wow, that's fast. Okay, so can everyone see this? Is it big enough? Should I make it bigger? Just hand sign. Is it okay? No, that was too much. Is that okay? Great. So that's Greylock, and for today's demo, as I said, I have a basically synthetic environment which is issuing HTTP, DNS, and ICMP requests, so basically running ping and curl in a loop against a list of domains, and some of those domains and IP addresses are part of either botnets or spammers or something like that, so that we have a base to check against. I'll just show it quickly. So basically this is these are lots of Docker containers running on that machine, and most of them here are just running ping against some addresses, and I hope the hotel Wi-Fi will let me do that. Well, you never know. Yeah, and then in one container there's running packetbeat, which with a very, very simple configuration. Can everybody see this? Great. So it's basically just collecting all the data on this interface. So it's the only network interface in this container. It'll collect ICMP packets, so in other words, pings. And it'll collect DNS requests, so checking which clients issue DNS requests to the DNS resolver and what their response was. And it collects HTTP requests. And all of that is being sent to this machine, which is, you guessed it, Greylock. Just show the inputs. So basically everything we'll get today will come in through the beats input, which is this one. There are also others, but they are not as interesting. So basically just one beats input where packetbeat is sending all its data. And let's take a look here. So, okay, that's it. Okay, so these are basically, this is histogram, which basically just shows in minute buckets, so how many messages have been received each minute since it has been started, and it has been started, I think, an hour ago, something like that. This one can go. So this one is just a basic view there. We get the data collected by packetbeat, and if we take a look at one of these HTTP requests, it shows the typical data, like how big the request was, the destination address where it was pointed. The port is, of course, 80 because HTTP. We get the response code. We get the actual query. So in this case, it's only head queries so that I don't cause too much traffic. And it also shows which client issued this request. So in this case, this is a little bit, well, simple because there's just one client issuing these requests, but okay. And if we take a look at a DNS request, we get the typical DNS attributes like if the client requested recursion of the resolver, and if it was granted, we get the type of query. In this case, it was a query for an A record. The A record is basically just pointed to the IP address of a domain name. So an A record says, for example, that netways.de is whatever 37.3521, something like that. We get the response code, whether it was an error or not, and also the typical addresses like destination address and destination port. Yeah, basically just the typical attributes. And the thing is that the data as it comes from packetbeat itself is not looking that way. So we have to rewrite it when it comes into the system. And Greylock has several different, unfortunately, it still has different ways of doing that. One of that is extractors, which will be applied to every message that comes in on a specific input. So in this case, there are none here because I'm doing it in a different way here. But what you could do here, let's just load an example message. What you could do here is, for example, check the IP address or a longer log line against a grok pattern, or extract it with a regular expression, or simply just copy the value and convert it into a numeric data type, something like that. The way we are doing it today is using the pipeline features. So if you've been using Greylock for a longer time, the pipeline features are relatively new. I think they've been introduced with Greylock 2.2, like, yeah, almost a year ago. And the pipelines are basically a very flexible way of running filters and pipeline rules, which we'll take a look at, against messages. So maybe first explain here. So usually if you get lots of messages, you want to categorize or sort them in a specific kind of way so that you can allow a certain group of people to, for example, to see just the logs of your web servers, while other people want to see maybe the logs of all your network appliances. So in Greylock, the way of categorizing and sorting things is called streams, which can be defined very simply by adding so-called stream rules. And in this case, we're collecting in a stream called DNS. We're collecting all messages which have the type DNS. This is preset by packetbeat or by the packetbeat by the Beats plugin in Greylock, and which have the facility packetbeat. So we know that it's from packetbeat and not from WinLogbeat or FileBeat or any other client that's sending stuff in there. So if we go to the stream, it also looks again like the search page in the first place, if it loads. So it will look the same like the search page I showed before, just with the restriction that it will only contain messages which have been generated from DNS packets which have been captured by packetbeat. This one doesn't want. Okay. Then that's too bad. Okay, then let's go back to the pipelines. As I said before, that's a way of flexibly filtering and manipulating messages. And now it hangs. That's not good. Yeah, live demo. That's why there's this smiley. Ah, there it is. Okay. So we have pipelines which we can connect to streams. So again, streams are basically just a way of tagging messages. So you can have messages of the same type or for the same application or whatever in the same place, and you can allow your users to search in streams. So for example, if you have a group of dedicated name server administrators, they probably want to have access to the DNS stream, but not to the HTTP stream or to the application stream, which will contain messages they are just not interested in. So we have this OSMC pipeline. And hopefully it loads the next page. I'm sorry about the wait. So should. Yeah, also it's Docker, so of course it will not work. And if everything fails, you can just reload. Hooray. Okay, so you have this, or we have this OSMC pipeline here, which contains several stages. So each stage contains a list, or at least one rule. And we can say, okay, if the messages match one of those rules here, and we'll take a look at these rules in the next step. If they match one of those rules, then go to the next stage. So basically we can have a cascading set of filters there, so that not every single rule and not every single extractor is run against every message. So you can filter out before that, and so maybe just save some performance for more important tasks. So we'll just take a look at the first rule, which we'll clean up. Okay, this is a bit small, so we'll take this one. So this is basically the same thing that's in here, but the zoom doesn't work, probably. Okay, so everyone can read this? Okay. So what we do here is we have a rule named clean packet beat, generic. In this case, it just cleans up the generic packet beat fields that are part of every message generated by packet beat. So it wouldn't. I'll go back to the universal search. So it. So it only cleans up the messages that are from that specific client program and none else. And okay, we're checking if it actually is from packet beat. So it has the field facility, and this is set to packet beat. And if it has this field and it has this value, then we are executing the rule. So if a message does not match this condition, then the rule is not executed, and all following stages of the pipeline will not be executed. Okay, just for is this? No. Okay, let's go back there. And what we'll do here is just basically renaming the fields that are contained in the message. So whatever comes from the beats input has the field names prefixed with the name of the beat. So in this case, the field client IP received from a packet beat message would be in the packet beat.client IP field of the Greylock message, and we want to have it in source address and destination address and stuff like that, just to have a consolidated view on all of these attributes, so we can run later rules against these attributes. So, do it differently, and hopefully it loads. So, yeah, there. So these are just internal log messages from Greylock itself, feeding back into Greylock, because dog food, hooray. And these obviously have different attributes. So in this case, there's nothing resembling a source address or destination address. And so all these messages would not be evaluated by the pipeline that I've shown before. So going back there. So this first rule is basically really just cleaning up the attributes of the field and removing everything that we are not interested in. And then in the next stage, right here, So this was just the first stage. And then we are cleaning up everything which is protocol specific, like the DNS fields. I'll just take a quick look in there. In this one. So these rules are relatively simple once you grok the syntax, and there's documentation for that, so no worries. So this one would basically just check if a message is of the type DNS. This is provided by packetbeat, so it says what kind of protocol was being recorded. And this one is then just cleaning up all the other fields. And okay, can you read the thing at the bottom? You at the back? Or probably not. Then I'll just do it differently. Life hacks. And for example, we are just modifying one of the values to not contain a trailing dot, which is typical for DNS requests. So usually contains a dot at the end to symbol, which is a symbol for the root. And we're just removing that so that our queries are simpler. So, and then we're doing that for DNS, HTTP, and ICMP packets, which is the only thing that packetbeat is recording at the moment. And then we come to the interesting stuff. Greylock 2.4, which will be released in 1 or 2 weeks, so I hope at least, will contain the so-called threat intelligence plugin out of the box. And the threat intel plugin is a plugin providing functions and lookup tables. So I'll just show lookup tables, which is also a new feature introduced in Greylock 2.3, I think. Which will contain lookup tables pre-installed and pre-configured to check various block lists and threat sources. And in this case, this is just an overview. So you can check against the abuse CH ransomware IP and, for example, check if one of your clients in your network environment is talking to one of those known ransomware domains or IPs. So this is a good indicator that they caught a Trojan or virus or whatever. And that's just a list. So you also have the spam list, so you can check your SMTP, your mail server logs against Spamhaus directly in Greylock and alert if you're if either you are listed on a Spamhaus list or if one of your client computers is speaking to Spamhaus, if it's listed there. So that's just an overview. And going back to the pipelines, that's in the third step. There we are. In which we will check the destination address and the source address and stuff like that against these various lists. So if you wanted to do that, it's also, again, let's take it a big one. So this one is pretty simple rule. So it would check if the message contains a destination address field, and if that destination address is not in a private IP range, like the ones defined in RC 1918, like 10.0.0.0/24 or 192.168.86, that one. You know what I'm talking about, you're professionals. So it would check if these fields are there and if it's not in a private IP net, and then it would just look that IP up in all these pre-configured threat intelligence lookup tables, like the abuse CH list. Maybe that works. Yay. So this single function will look up if the IP address in the dest address field is listed in any of these lists here. And if it was listed, then it has a attribute that's called thread indicated, which is basically just a Boolean value, true or false, and which can be added to the message with the setFields function. So we take the result, just add it to the message. And if we take a look there, so we're searching in the last 5 minutes, should be quite enough. And we can check if there was anything with a thread indicated. And yay, there are some. So we have this HTTP request, which is where a client is talking to an IP address which was listed in the abuse.ch ransomware list. So there's probably some client which has one of these Trojans which encrypt your hard disk and then try to get ransom for it. We also have a few else, like a DNS query for one of those. What's that? Could be some botnet command and control server, whatever. At least it looks suspicious already, the domain. So the DNS request was for this domain, P27D. Okay, you can read it. And what Greylock detected there simply by querying the pre-configured block lists is that this might be a threat. So we can also add additional details there, but usually it's sufficient to know that there was a threat at all. So that's it. And now that we have all this information in our messages, like this Boolean flag if it was a threat and all the other protocol details, we can add them to a dashboard. So for example, if we wanted to know all threads from the last 30 minutes, we can just run the query. And now in the result field here are only messages which are basically suspicious, so which have this attribute set. And we can check in, so probably not big enough. Okay. And we can check what the actual, what the actual destination address has been. So can take quick values of the destination address. And so we see, okay, this one is probably me. This is this computer, yes. Thread indicated, okay, that's strange. But probably there's a, okay, I got it. It's, this part is because we're now searching through all messages and not just the DNS or ICMP messages. So there might also be a source address where a thread was indicated or a DNS query for a domain where this was indicated. So if we just want to know it for the destination address, we can use this one. So the thread indicated field is basically a consolidated field. It's a flag that just becomes true if any of the other thread indicated fields was true. So if the, for example, if there was a DNS request for one of those domains, or if there was communication via HTTP or an ICMP packet sent to one of these addresses which are listed on those lists, then it will be consolidated in the thread indicated, which is, by the way, what we're doing in this rule. So get it bigger. Inflate. So here we just check if any of the other thread indicator attributes has been set. And if it's the case, then we just write it into this field to make lookups easier, just like I did there. And easier means, of course, that you can get false positive just like I just did. So if you just check for the destination address, and that again, so that looks better. So these are probably IP addresses which have been listed on any of those block lists, probably abuse.ch. So that's just an overview of the top 5 in this case, and then the long tail there. We can also check how many messages have been found with this thread indicator, which is basically just the histogram there, and we can add that to a dashboard. So, for example, for all connections or just for DNS. And since I did that before, we'll just take a look on that. So I think I'll make that one smaller a bit, so you can see more. So the details aren't important there. It's just that again we have here basically a breakdown of all the DNS requests which have been successful. So, and here we see to which destinations they were. So clients try to resolve whois.rn.net. So incidentally, this is probably Greylock itself, because I also have a whois lookup running on each message. And so the next one, Google CO, the UK, stuff like that. So these one are the real ones. So we could probably filter that out. Right now in that setup that I'm running, PacketBeat is just recording all the traffic inside that Docker network. So it's also where Greylock is running in. Yeah, we see a number of successful requests, and we can also just replay that search in the actual search interface once I'm authenticated. And this was simply a query for status OK in the DNS stream. And this is what this is based on. And here we have possible threads where this DNS question thread indicated attribute has been set. So some client, so probably my very sophisticated ping and curl Docker containers have been trying to resolve one of these domains, which look, again, very suspicious, very often, and which has been recorded here. And also we can here replay the original search query. And yeah, it's incognito mode. That's why it's not saving that stuff. And again, here it's just thread indicated true, so it's that flag that has been added via our pipeline rules to the messages in the DNS stream. So I think, okay, that's in the other dashboard. So we also have the usual metrics here, like the response time of these DNS requests, which might be interesting. So if that goes up, you know that something is wrong with your DNS resolvers. And again, we can here just see what it's based on. So it's basically just an unqualified search. So every message is in there from the DNS stream. So every DNS request, and we craft it there for the response time. So we can also just show it here. We have this response time field, which has been named that way by our cleanup rules. And we can just generate a chart from that and add it to an arbitrary dashboard that we already created. So you can have the overview there. And then, of course, something that must not be missing is, of course, also the map widget. So we see where all the requests, in this case, the destination address, where they are located. And yeah, it's mostly Europe and the US, and some in Russia. Okay. So as I said, the informational value of the map widget, in my opinion, is not very high, but it's a good eye catcher. And then, yeah, basically we have here the stats generated from all the packets generated by PacketBeat, for example, the response time rate. So we can have, again, this time is working, okay. Again, it's an unqualified search, so all messages from PacketBeat will be included in that search, and we can check the response time again, but this time we can just take a look at the typical statistics that might be interesting. So the mean response time is very bad, like 580 milliseconds, which I blame the hotel Wi-Fi. And also we can add that to other dashboards. So that just as an overview. And now to a interesting feature there. So Greylock supports alerting out of the box, also in the free version. And we can add a, what is that? Let's just delete that and make a new one. We can make an alert condition there, which will alert us if there is any message in the DNS stream which has the field, let's just call it DNS thread, which has the field thread indicated. That's the one we had have been using before, if that is true. And so with all these pre-processing of the messages, so basically consolidating the field names there from the specific field names into a commonly used one like destination address, and then running that destination address against a battery of our block list lookups, and then again here setting that simple one, that thread indicated attribute. We can just check it here in the alert condition, check if that thread indicated thing is true. And we want to include at least some messages in the backlog, and grace period, I don't care. So, and there it is. Okay, and now if we take a look at alerts, it says there has been, okay, no alerts with that one. Let's check it. Get it true and type DNS. I could also just check the DNS stream in this case, but just to show combined one. Okay. So there have been some, and the alerts. Ah, yeah. Okay, there it is. So it takes some time because the alerting is basically based on recurring searches. So it takes up to 60 seconds, depending on your configuration. Can take some time until an alert is actually issued. But in this case, it found some messages which have been detected to contain threats. And you can basically add notifications for that to your monitoring system. You can just send emails. So out of the box, there's an HTTP callback, which basically just sends an HTTP post to a configured endpoint containing details about the alert, or an email to you as the administrators. But there are also integrations for OpsGenie, PagerDuty, and all that stuff that you usually want to have. And yeah, so basically that's the whole process there. So basically collecting the data with some clients such as PacketBeat in your environment, and then cleaning up the data so you can make sensible searches on them, and then basically creating alerts on these cleaned up messages. So, are there any questions up to now? Yes, no, maybe?
Are pipelines the preferred way to enrich data? Are extractors not to be used anymore?
Preferable in a way that they are the most extensible and the most powerful feature to do that. If you have, in quotes, simple messages and just want to enrich simple stuff, you can still use the extractors. So, but our plan is to basically replace the extractors with the pipelines, but still have the nice UI and the UX of the extractors, because they are arguably very simple, And pipeline rules are very complicated compared to extractors, so we'd like to have a very nice UI and nice UX for that. So basically that the old extractors will be auto-generating pipeline rules for you. But for now, so if your needs are met by the extractors, then just use the extractors.
Some more questions, please. Come up, guys. All right.
Okay.
Oh.
Can you configure more lookup tables, or is it just this set of hard-coded things?
No, you can configure your own lookup tables. Right now we have, well, it's against a multi-stage system, so we realized that if you have a lookup against a remote source like a block list or something like that, you want to cache that eventually. So that not every request will just go out over the internet somewhere. And so we have caches for that and data adapters. And the combination of these data adapters and caches, they're called lookup tables. And right now we have data adapters for these block lists being delivered right out of the box with the threat intelligence plugin, which is also included in Greylock 2.4 out of the box. And we have data adapters for flat files like CSV. So you can just add your CSV files and look up your, don't know, the room number where a certain computer is being placed or something like that, or whatever you can think of. You can add that, and you can add additional data adapters via plugins. So if you have another nice block list, or if you have some other source of information like a relational database, for example, or your asset management system where you want to look up things, you can just write an adapter for that and add basically an arbitrary number of them.
All right. Thank you very much for the talk.
And if you have more questions around here in the conference, and if you have questions, just come to me.
Okay. Thank you very much.